Welcome to another lecture in this Q&A section of the Database Engineering Fundamentals. And today we have a question from Kirati. Sorry if I didn't pronounce your name correctly. It's a very good question, actually. It says, hey, I have a Postgres using sequential scan rather than index-only scan. Why is that? And that's a very good question. Let's take a look at what was Kirati's question here. I'm using PostgreSQL. I have created a table with 4 columns: ID, first name, last name, date of birth, and I created an index on the ID field, which is a primary key as well. When I do a select query like this, which is a select ID where from, obviously he forgot to add the table here, select ID from blah blah the table where ID equal to, he is getting it is using a sequential scan rather than an index only scan. What's the issue here? The table has only 7 rows. Even if he didn't say that, I would have guessed that his table is small. Right, so my guess is here. So what is happening here? Right, so I already answered here, but I'll give you a hint of what's happening here. You see, Postgres or any database planner we're gonna understand how things work, right? We have the data of the table in a file, right? And we created also an index, which is another file. And the index has the structure of, we talked about the B-tree structure for an entire section. It's a complex structure with so many intricacies, right? Where we have a root, we have intermediate nodes, we have this, we have that, we have leaf nodes. We have complex structure here. And we have the data file, which is just a dump of everything that is in the table. So when we load the database and we start querying the table, what the database will look is like, okay, we have the data file and it's a single page. Why is it a single page? Because it has only 7 rows, and the 7 rows happen to fit neatly inside that page. A page is around what, 8K in Postgres, I think. So this is way too small of a table, right? So it's a single page. And here's what the database says. All right, what I'm gonna do is actually, yes, you start using the ID field, but guess what? It's not even worth it for me to go to the index, because to go to the index, I have to do 2 things. I have to go to the index, I have to fetch the index, I have to build the B-tree index in my memory, and then I have to traverse it just to find everything that has ID equal to. Versus I know the whole table is on 1 page, and that will cost me 1 IO. So here it is. I'm gonna do an IO, and I'm gonna pull it in memory, and that goes to the heap, as we talked about it, the Postgres heap. And then that page in the heap was there. All right, here it is, user, because we just read all the things that are ID equal to, and it's a single read. It's a sequential scan in this case. That's why tables, right, in this particular case, that are too tiny, the database will just do a sequential scan on the heap, right? It will just fetch 1 page, and that's 0 cost almost to Postgres. Right? Now, here's where it gets interesting, and I got bitten many times that I have count with this, actually. And here, so I have a tiny table, and I start querying this like what Kirati did here, right? I was querying it, and the plan started getting cached. It says, oh, this table is too tiny, so sequential scan is the best. I don't want to go to the complex B-tree and scan many indexes to get my results. I was going to do a sequential scan because it's just it's a simple table, it's a small table. And what I do is, immediately after doing all the queries, I would insert my data. And when I do that, right, what will happen is I start like inserting 3 million rows, right? And immediately after 3 million, I didn't give the database time to breathe. I would start querying, right, for a few minutes. And my queries are so slow. Why is that, right? Why are my queries slow? Because the database thinks the table is small. So if I issue a query, the statistics, and we talked about statistics in the course, the statistics which tells the table how many rows are in there are not up to date with the 3 million rows that I inserted. So the planner thinks, oh, it's a table that is small. Let me go and query it. And when it does that, it says, uh-oh. It starts doing a sequential scan of an actual, instead of an actual performant B3 scan. Because remember, B3 scans or the index scans are very amazing when you have large amount of data, because you're going to traverse few blocks, but then you're going to find exactly what you want in the B3. Immediately go to that, right? That's the problem here. The problem is the planner is out of date, right? The cache, the stats are out of date. So the planner thinks, let me do a sequential scan. So it starts scanning the entire heap, fetching millions of pages. I'm exaggerating, thousands of pages to find what I'm looking for. Why? Because it was out of date. Obviously, this is a very common problem when you just insert the data and immediately you queried it. That's something you have to watch out for. That's why after inserting a lot of data, you have to do a vacuum in case of Postgres, and in case of Oracle, you have to do a vacuum analyze, I suppose. We'll do a computing the stats again. It will just do a count again, says, okay, this is how many active rows are there. I'm gonna update my stats, so the planner will make smarter decisions. And in Oracle, I think it's called gather schema stats, and in SQL Server it's called something else. And that's updating the schema stats are very, very critical in this particular case. So this, I thought it was a very good question, and I thought I'll talk about it here because it's just really something you have to watch out for. And very good observation, Karate. I like that you guys are actually looking at the plans. It says, wait a minute, I'm using an index. Why is it not using the index? It's a very smart thing, right? Even with an index only scan, it's not fast enough, right, to fetch the index compared to just having the one page, right? If you add a few rows to your table, more few rows, that's 10,000 rows, you'll immediately feel. Hope you guys enjoyed this Q&A lecture. See you in the next one. Goodbye.